Hi friends, we are given this problem f of x equal to an plus sine pi x when x belongs to closed brackets of 2n and 2n plus 1. What does that mean? This is even and this is odd, right? And bn plus cos pi x when x is between 2n minus 1 and 2n. That means it is between even and odd. Sorry, this is odd and even, right? Here it is even and odd. Okay, between even and odd, and this is between odd and even. These are closed brackets, these are open brackets. Right, and a and b and both are real numbers, maps from f, maps from odd to odd for all integers n. Then, what is the relation between these coefficient, these variables, right? A n plus 1, b n plus 1, whatever. Okay, so let us understand this problem. What is it given? So, for example, when n equals 1, what does that mean? This is 2n and 2n minus 1. That means it is between 2 and 3. Right. And what is this? This is 2n minus 1. That is 1 and 2n. 1 and 2. That is this. Right. This is 1 and 2. And this is 2 and 3. That means what? Between 1 and 2 the function is b1 plus cos pi x between 1 and 2. And between 2 and 3 it is a1 plus sine pi x. Right. This is when n equals to 1. Right. Similarly, when n equals to 2, what will happen? N equals to 2, then this becomes again 2 to 4 and 5. One is between 4 and 5. The other is between 4 minus 1 and 4. That is 3 and 4. Same. Then this becomes b2 plus cos pi x between 3 and 4 and a2 plus sine phi x between 4 to 5. Right. It goes like this. Between every even numbers, between closed intervals of closed intervals starting with an even number, it is sine, and open intervals starting with odd number, it is cos. It goes like this. Okay. Now, this function is continuous all the time. Right. F is continuous all the time. What does that mean? What does that mean? Between 3 and 4. Right. This one, if we are approaching from the right hand side, and this one when I'm approaching from the left hand side, right? This is 2 3 if we're approaching from the left hand side, and 3 4 if we're approaching from the right hand side. Both should give the same value, right? Both should give the same value. And we're approaching 3 from the left hand side, that is this one. Basically what we are saying, a1 plus sine pi x, or in fact sine 3x, sine pi 3 times pi, sine 3 pi should be equal to this one, b2 plus cos again pi x, that is 3 pi. Right. We know what is our sine graph. Sine graph is like this. And what is our cos graph? Cos graph is like this. Okay. Cos pi or cos 3 pi, cos pi pi, this is all is minus 1. So b2 minus 1 is actually equal to a1 plus sine all multiples of pi. These are zeros. a1 plus 0. Right. What exactly we are saying? b2 equals to a1 plus 1. Okay, b2 equals to a1 plus 1. Similarly, we have just taken one example of this, but we can put actually n here, n or 2n here. Then also we'll get like this. What we'll get? bn plus 1 is equal to an plus 1. Right. Or bn is equal to an minus 1 plus 1. Okay. bn equal to an minus 1 plus 1, or bn plus 1 equal to an plus 1. Right. What exactly is this? That means bn equal to an minus 1 plus 1. That is this one. Right. This is equal to bn equal to an minus 1 plus 1. So, okay. Okay. So, D is definitely right. Okay. What we have done, we had checked at 3. Right. Now, let us check at, let's say, somewhere else. Let us check at, so for example, 2. Okay. We'll check at 2 before 2 and after 2. We are approaching 2 from the left hand side and from the right hand side. Okay. When you are approaching 2 from the left hand side, what is this? That is this part, right? Then it becomes b1 plus cos pi into 2, which is cos 2 pi. Right. And when you are approaching from the right hand side, if you are approaching 2, then that becomes this one. Right. That is this one. When you are approaching from the right hand side, this one. That is a1 plus sine 2 pi. Sine 2 pi is anyway 0. So a1, this is a1 plus 0. And b1 plus cos 2 pi is 1. Cos 0, cos 2 pi, cos 4 pi, all are 1s. What does that mean? a1 minus b1 is equal to 1. Similarly, a2 minus b2 is equal to 1. Similarly, an minus bn is equal to 1. We can directly substitute instead of this 2, 3s and all. So we can in fact put n, 2n and all. So an minus bn is equal to 1. Right. So what we have done, this 2n, this part and this part should be equal to this 2n, that is approaching 2n from the left hand side. That means bn plus cos pi into 2n, cos 2n pi should be equal to an, that is approaching this one from the right hand side. Right, approaching 2n from the left hand side is this, that is bn plus cos 2n pi, and approaching 2n from the right hand side is an plus sine 2n pi. Right, sine 2n pi is anyway 0. Right, sine 2 pi, sine 0, sine 2 pi, sine 4 pi, this is all zeros. So this is equal to an plus 0. And cos 2n pi is actually equal to 1. So bn plus 1 is equal to an. That is nothing but an minus bn is equal to 1. Right. When we substitute directly with respect to, when we try to equate this one at 2n and at 2n. And while you have to try to equate it to n plus 1, then what you have to do, instead of 2n, there is 2n minus 1, right? Instead of that, we can write it as b of n plus 1. So if it is between 2n minus 1, instead of n, if you put 2n n plus 1, it becomes 2n plus 1, right? And 2n plus 2. Right. So this becomes bn plus 1 plus cos 2n plus 1 pi. bn plus 1 plus cos 2n plus 1 pi should be equal to an plus sine 2n pi. Sine 2n pi. Earlier we did with regular numbers. Now we are doing with this n notation only. Okay. So bn plus 1 plus cos odd pi, that is minus 1. Right. Minus 1 is equal to an plus sine pi. This is actually equal to 0. Right. Sine pi equal to 0. What does that mean? bn minus n plus 1 minus 1. Instead of n plus 1, if you put n, then bn minus 1 should be equal to an minus 1. Right. So that is nothing but an minus 1 minus bn is equal to minus 1, or an minus 1 or bn minus an minus 1 is equal to 1. Whichever way you write it. So again we got the same equation. So this one we made it, we substituted n plus 1 instead of n, so that we match this 2n plus 1 and 2n plus 1 also here. So we get n plus 1 here. Right. Very, very simple problem. So when a function is continuous, what does that mean? That means very, very basic thing. Limit from the left hand side should be equal to limit from right hand side. At the same time, f of whatever, wherever we are finding it. So f of x naught should be equal to this limits. Right, limit from the left hand side, limit from the right hand side. Basically, the limit of the function should exist at that point. So limit x should exist as x approaches 2n, and at the same time f of 2n should match with this limit. So that is meant, then we can say the function is continuous. When a function is continuous, what does that mean? Graphically, if you are trying to say, so if there is a function like this, okay, if there is a function like this, and if there is a hole, right, and the function is defined like this. If I are approaching the limit, let's say this point is actually 2 and this point is actually 4. Okay, here the limit is 2. Limit, let's say this point is 3, limit x tends to 3 is 2. Limit x tends to 3 is 2. Right, we are approaching 2 from both the sides. But f of 3 is 4. F of 3 is actually 4. So that's why this is not continuous. If f of 3 is also 2, f of 3 is also 2, then this graph is continuous. Basically, the function should have, so let's say this point was not there. Right, then f of 3 is not defined. What does that mean? F of 3 is not defined, but limit x tends to 3 is 2. Then that function is not continuous. The function is continuous only when the limit is also 3 and value of the function is also, sorry, limit is also 2 and value of the function f of 3 is also 2. So both conditions should get satisfied. The limit also should be same as the value of the function, then only the function is continuous. Right. In this case, because there is a closed bracket, one side you are approaching, the limit as well as value of the function is same because it's a closed bracket. One side it is an open bracket. So from one side we are taking the limit, another side we are taking limit as well as value of the function, and we are trying to match both sides. Right guys, simple problem, basic substitution. Right, thank you.